Good evening, everyone. Hope you're having a fantastic week as always. Back for another evening of Cryptopals, crypto programming, building crypto stuff, breaking crypto stuff. So, hope you enjoy. Before we get going, I've just got one piece of housekeeping I'd like to take care of, and that is if you haven't read this post or this advisory by Jamie and Emily, I can't recommend it enough. It's an absolute banger. I'm not sure if I've met Jamie before, but Emily is very, very good people. And this is a write-up of a bug chain in Tailscale, the kind of mesh VPN software. And it's just a really good read, and it's a really good example of kind of threading the needle in the case of kind of quirky, curly bugs. But when you put them together, they tell a really, really good story. So if you haven't already, do check that out. I'll drop a link in Twitch chat right now. And if I remember, I'll put a link down below for those watching on YouTube. Hello to you. Knowing me, I will forget, but we'll see how we go. And with that out of the way, let's get cracking with some crypto programming. So we're working through the Cryptopals series at the moment. And last stream we worked through Byte-at-a-time ECB decryption simple, in which the Vault 1999, welcome my friend, good to have you back again. Last stream we worked through kind of consuming an oracle that encrypts a string we choose and then suffixes it with a secret string and it encrypts it with a random key. And by repeatedly giving various special inputs as our string, we were able to deduce unknown string byte by byte. I haven't git pushed that yet because I'm lazy, but also I didn't last stream lift any of the code we wrote into our utilities file. And the reason for that is I know we've got something called Byte-at-a-time ECB decryption harder coming up soon, and I'm not sure how that's going to relate to simple, and if we're going to be reusing code, if we need to fix or maybe modify some code from the simple case to account for some sort of harder case. So until then, I'm going to not bother to lift stuff into util. Irregardlessly, this evening we're looking at ECB cut and paste. So let's get into it, shall we? Okay, we need to write a key value parsing routine as if for a structured cookie. The routine should take foo equals bar and baz equals quox and zap equals zazzle. So it's kind of like a URL query string format. You got key value pairs separated with ampersands. So our code should take this and give that some sort of dictionary object in JavaScript, dictionary in Python. Now we need to write a function that encodes a user profile in that format. I'm guessing it's the URL query string format, given an email address. So we need to write a function such that over foo@bar.com, it builds this object with email foo@bar.com, uid of 10, and a role of user, and then serializes it out to a query string. Okay, simple so far. Our function should appropriately handle ampersand and equals characters so that the user can't do injection. Makes sense. Now we need to generate a random AES key. We need to encrypt the encoded user profile with the key and provide it to the attacker. Oh, we need two functions, one that encrypts and one that decrypts and parses. So it probably takes a query string back to an object. Using only Okay, so we can give input that goes into the profile forward to build this, to build that. We need to use it as an oracle. Okay, so I'm guessing that then feeds into this, the encrypt function. Using that as an oracle, make a profile with role equals admin. Okay, cool. Makes sense to me. let's yoink this and slam it into a Python file and get cracking on some of these helper functions. What is this called? ECB cut and paste. Yep, ECB cut and paste. And it's number 13. Yes, it's number 13. And I haven't set my interpreter. There we go. So I'll create a new Python file. Set to challenge 13 ECB cut and paste. To our boilerplate. By the way, I didn't have anyone poke their head out in chat this time to help me with the sound test. So if I'm coming in too quiet, if the music's too loud, please give me a yell and we will fix that up. But otherwise, I'm going to hope that I've got the hang of this audio thing by now. So, write a key value parsing routine that takes a query string and produces an object. I'm pretty sure Python gives that to us. Parse query string. URL lib.parse sounds right to me. I think it's something to do with QS. Parse QS. Parse a query string as a string argument. Return it as a dictionary. We don't get given an example, but we'll have a play with it. Yoink. Drop into a REPL. From that, import parse QS. Nope, there we go. Parse QS over. What was the example we were given? Don't need you anymore. Here we go. Grab that. Slam it in there. Ah, interesting. Okay, so parse QS gives us key values, but the values are represented as lists, which isn't quite what we wanted. That's probably because if we have another foo equals fuzz, yeah, it wants to go and put the bar and the fuzz with each other. So this is not quite what we were asked for. Strict parsing false. No, that's not what we want. We can probably just do this. K V for K V in that. No, we've got to do that dot items. Cool. Instead of KV, let's do KV0. Foobar, Bazquax, Zap Zazzle. That's what we want. So Python didn't quite give us what the challenge wanted, but close enough. So I'll pinch that. And we'll create a function, query string to dict, which takes a query string as a string and returns a dict. From URL lib.parse import parse QS. What was that parse QSL? Wolf's telling me to check out the function right underneath. Is that parse QSL, is it? QSL. Foo bar baz quack zap zazzle foo fuzz. Let's actually look at what here. Yep. So at Wolf, you're saying parse QSL. It's returned as a list of name value pairs. So still not quite a dictionary. In fact, I dare say it's further away from what we want. I like this awfulness. Gives us exactly what we need. But thank you, Atwolf. I do appreciate the set of eyes, as always. So query string to dict. Let's just. This was it, wasn't it? And we'll tidy it up. There we go. Parse QS happens over QS. Why am I getting yelled at? Oh, I need to return it, that's why. Cool. And we better write a test to prove that it works. Oh no, I think you're right, Wolf. If you just do dict over that, that's pretty good. We are in URL lib. We're in URL lib. No, you're right, Wolf. Doing dict over a list of key value pairs. But I mean, so here's the age-old question, right? Given duplicate keys, my first one was returning foobar. This is returning foofuzz, which is kind of like, do we want the first or the last? Which is an age-old thing called HTTP parameter pollution. The challenge isn't specific about which one it prefers. So let's YOLO and do this, because this is much, much nicer. Pull in the QSL, good. And then this here can be the query string. Yeah, it's much cleaner. So this here, oops, QS to dict over this needs to return something that looks like this. And now I bet Python's not going to give it to us in this exact shape. So we'll just cheat, and whatever the test comes back with, we'll slam that in as the expected result. Run our doc tests. Yeah, it puts it all on one line. Same difference though, right? Foobar, baz quox, zap zazzle. Yep, I'm happy with that. And run the tests. And would you look at that, they pass. Alright, part 1 down. Now write a function that encodes a user profile in that format, given an email address. So email address goes in, and then this comes out. No, this comes out encoded as that. Yep. So this is going to be email to QS. Email's a string, and it returns a string. Actually, why did I bother doing that? So the profile is this. The email is going to be email. We need to quote the keys. That's the profile. And then we need to return profile to QS over the profile. And then we need to write that. Actually, Python probably gives us one, doesn't it? To convert dictionaries into query strings, we do URL encode with do sequence to true. Key value pair separated with ampersand. Sounds good to me. What does the do sequence equals true mean? I think this is not related because do sequence is to do with the list of key value pairs, not the dictionary. URL encode. That's such a weird function name. So URL encode over. Let's nope. How do I select by column? That'll do. pinch that, email equals foo@bar.com, slam that in. So the profile, that looks good to me. So if we just URL encode profile, I mean, that's what we want anyway. I don't think, yeah, so the at wasn't being percent encoded here. Ooh, do we want to do this strictly by the letter? If we be fancy and actually URL encode it, are we going to end up with problems? And we're told to quote or eat ampersand and equals. I've got a feeling percent encoding is going to make it's going to make life hard for us in various ways, in a lot of ways. We can start off with doing things the hard way, and if they get too hard, we can revisit our decision later on. It feels messy to not do it the hard way. It feels messy to not URL encode stuff like that, or indeed like null bytes, like, because null bytes are going to end up in here, I'm sure. I don't imagine that they really want null bytes in here. I'm going to do it the hard way. Let's just see how we go. So it turns out URL encode, oh, thank you, kernel, for whatever that means. Well, it turns out URL encode over a dictionary just kind of does sort of what we want. Let's do that and cross our fingers. So we don't need profile the query string. We just need URL encode and some tests. This should give us something similar to this. That's got to be, I've got to change the function name here, email to QS. Oh, hold on, we didn't expect that at all. We expected this, didn't we? And we're still not going to get it. But it's at least closer. Drop that there. Quote it. So the URL encoding is the only difference there. So if we just %40, tests should pass. Yep. Well, if URL encode has a safe option, you can specify characters you want to skip the encoding of. Yeah, but I bet we're going to be chucking like BYO padding into this. And I feel really nasty calling URL encode with safe characters being hex 4, hex 5, hex 6, hex 7. You know what, maybe it's not going to be a problem anyway. Let's just forge on and let's see how much trouble we get into later on. Yeah, well, that's not the thing I'm so worried about. It's the ECB cut and paste. Maybe we don't need to bring hex 7 to the party. Okay. Generate a random AES key. And then do encrypts. And then decrypt and parse. Okay, so I'm gonna call it the profile oracle. And we'll see if that's a suitable name the further we get. It's gonna have a key, which is bytes. And then upon initialization, self.key equals from secrets import, is it token bytes? Yep. Self.key is token bytes. Block size we're going to have be 16 for AES 128. So the key is going to be block size bytes. That's all we have to generate. And this encrypting, it's going to be ECB, right? Yeah, ECB. So it's going to have an encrypt and a decrypt. And the encrypt happens over... You know what? I'm not going to have it take an encoded user profile. I'm going to have it take an email address. Which I think is kind of the spirit of it anyway. So encrypt is going to do profile QS equals email to QS over email. I need to pull in our encryption from util import ECB encrypt and ECB. Where's my decrypt? Comma. ECB decrypt. There we go. So we've got our ECB encrypt and decrypt. Encrypt handles padding. Yep, automatically pads it. And decrypt automatically unpads it. Cool. So they handle padding for us. So encrypt is going to return bytes. And it returns encrypt. The plain text is bytes. Oh, so it's going to be profile query string dot encode. And the key is going to be self.key. Beautiful. And decrypt. Decrypt decrypts an encoded user profile and parses it. And our target is for role to be admin. So I'm going to have the decrypt return the role. At Wolf, way to go Twitter, it took 5.5 days to get the archive and it's 11 whole megabytes. GG Twitter. I'm sure they're getting crushed by people asking for takeout options and exports. So decrypt takes a query string, which is a string, and it's going to return a string. Let's just document this encrypt. Serialize email into a profile query string, encrypt it and return it. Using AES 128 ECB and return it. And you know what? This email to query string, I feel weird about UID being 10, role being user. Let's parameterize those. Let's give them defaults, but parameterize them because it just feels weird otherwise. UID is an integer with a default of 10, and role is a string with a default of user. Just to kind of avoid these hard-coded values. And then we've got query string to dict already. Yep. So the decrypt is going to plain text equals decrypt. This query string is encrypted query string, right? Because we're encrypting. This is kind of just feeling a bit weird. Yeah, encrypt the profile provided to the attacker. Yep, okay, cool. So we're going to decrypt the encrypted query string with the key being self.key. Profile is going to be query string to dictionary over the plain text. And then we return plain text, we return the role. Why am I getting yelled at? Why is it a union of integer and bytes? Because it's got to be profile. Duh. Duh. That looks better. Decrypt takes a query string, decrypts it with the key to get plain text. Plain text gets query strings addicted to become a profile. Then we dig the role out of the profile and return it. So decrypt. I'm going to delete these. Decrypt. Delete those two. Decrypt using AES 128 ECB. Deserialize to a dict and return the dict's role value. So now our goal, do we need, no, we don't really get given good test cases for these. What are you yelling at me for? Encrypted query string is not a string, it's bytes. Good call. And we have to decode the bytes that come back from the decrypt. Look, let's write a test case for decrypt. Oracle is a profile oracle, and the profile is foo bar role admin. No, let's do not admin. Let's spice it up. So now oracle dot no. Because encrypt just takes an email. Let's do ciphertext is oracle. Really, if we just do oracle.encrypt over an email address, foo@bar.com, and then over the top of that we do oracle.decrypt, we'll just always expect to get, hang on, role user. We expect to get user back. Run the tests. So like it's a super shitty test case, but it's kind of just proving that encrypting anything and then decrypting it, we at least get back a sensible value of user. It'll do for now. Famous last words. Now we've got to attack it, right? Using only the user input to profile 4 as an oracle to generate valid ciphertext. So I'm not using profile 4, I'm doing oracle.encrypt over an email. Using that input, make a role equals admin profile. I'm going to pinch that to remind us of what we're doing. Using only oracle.encrypt. Nope. Yep. Make a role equals admin profile. Let me have a think about this for a second. I'm going to cheat. I'm going to have the oracle have verbose bool equals false. So let's build in the lab, let's build a debugging oracle that will basically give feedback as it operates, just so we can kind of understand a bit more about what's going on. If self.verbose, that's right, we've got to set it self.verbose equals verbose, and verbose is a bool. If self.verbose print in fact, let's grab that and do ciphertext equals that, and then return the ciphertext. Same thing, just splitting it up. Self.verbose encrypt, the email got turned into profile query string, which got turned into ciphertext. And these bangars are just ways of getting Python to kind of escape and quote stuff nicely for us. You don't need it for dictionaries though, which is what this function gives us back. Oh no, it gives us a string back, so we totally need bang-r. So the email got turned into this, which became the ciphertext. Decrypt. Let's print, no, if self.verbose. Let's print decrypt turned encrypted query string into plain text into profile, which is a dictionary. We don't need bang-r there. And then that turned into, no, let's just do that, because we can just eyeball that profile and check to see what the role was. Okay, so now let's do oracle is the oracle with verbose equals true. Turn on the debugging behavior. And then do, let's do ciphertext equals oracle.encrypt with an email address of foo@bar.com. And then plain text equals oracle.decrypt the ciphertext. And run our main and see what we get. So encrypt turned foo@bar.com into that, into ciphertext, and then decrypt turned the ciphertext, which is a bit of a mess, into the query string, into an object, and then the role was user, so we lose. Good day, sir. So now we're obviously going to be using ECB's properties to be able to kind of have it poop out blocks and then reorder them, such that role equals user shows up somewhere. Oof, this is painful, because user and admin are different lengths. I was thinking if we just basically caused this to be, this equals to kind of finish a block, and have the last block be user. No, it wouldn't work anyway, because role equals user comes right at the end. Does it come right at the end in their examples? Yeah, it does. How are we going to do this with my stupid URL encoding going on? Because it's right at the end. If we had admin there, we can't bring an ampersand to the party to truncate it early, and we can't bring padding to the party, because our padding is going to be hex encoded. Ooh, this is painful. Can we even do this with the URL encoding? I may have made a mistake, because my unpadder is super strict as well. If it doesn't get pristine padding, it chucks an error. Have I screwed up? Is there a way to solve this? with the decoding. Humble brag, my code is too good, lol. I wouldn't say it's good. I'd say that I want it to be elegant and use the built-in proper, and I've screwed myself with it. I accidentally fixed the bug. So yeah, you're not wrong. My code is too good. Can we still make this work? Because role's got to be precisely admin, doesn't it? Role equals admin. No, we can still do this. We can still do this. I think. Let me just sketch some things out. I'm going to put a pipe at the beginning of each block. So we've got a pipe, and then 15 append space. They're the starter blocks, aren't they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. New block. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. New block. Yeah, it seems right. Okay. So, what if on the first one we have email equals, we can't control that. And then we have oh no, I think we're still screwed. I was gonna do role equals. No, we still can't do this, can we? Going to basically roll. We're going to have email being a whole bunch of spaces, then roll. But then if we stop there, we get an ampersand. We need that to be equals. Unless we finish the block with roll, then on another one have email equals and a whole bunch of spaces. At the start of the block equals. No, because then we lose control. Vault, can I link the challenge? Of course I can. Set to challenge 13. That's going to be what comes next. UID. It's going to be ampersand. We can cause that to happen, so we get a block to start with equals, but then we're going to have, we don't have control anymore. We can also have email equals and then a whole bunch of whatevers, and then we can have ampersand there. No, we can cause it to have ampersand there. We can do that. Then we can do email equals and then start the next block with roll. So we've got ampersand roll, but then we can't do equals. I think we messed up. We may have messed up. And @wolf, will your safe chars thing work anyway? Because query, what does URL encode take? query as a mapping. Always returns a string. You can't have hexo7 in a string anyway. We're going to have to hand roll our own busted ass URL encode that doesn't encode things like hexo7, hexo8, hexo9. What do the docs for quotes say? Or encode, I should say. Have I messed up? Because we can't get an ampersand here no matter how hard we try. We have to build entire blocks at a time. Most useful place to be building is going to be in this block here, because this one's always going to start with email equals, which is not desirable. Email equals blank and roll. But I can't get an equals to pop off. Like if I wasn't percent encoding everything, what I would just think I would need to do is email equals, this is the start of new block, admin, admin, 16 minus 5 is 11, which is hex B, isn't it? These would all be hex B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That takes me to the end of the block. And then I stop caring, I just, it would then be ampersand u would equals, but I don't care at that point. What I would then do is take this block and know that it's a valid terminating block. And I would have another one, which was email equals ampersand u would equals 10 ampersand roll equals, and then have email be long enough to basically push roll equals so that it butts up against the end of a block. Then it would be user. Then I would take this block here, copy it, and do a cut and paste attack. And then this user, I would yeet it away, put that there, and I think we're good. Email be a bunch of spaces or junk data, whatever. U is 10, then roll equals admin, and then I've got my trailing padding, win. But I can't put unsafe bytes here, because URL encode with email being ZZZZ and then like hex OB. Oops, that's got to be turned into a dictionary. This has got to be bytes. You get this nasty percent OB, and that's not hex B. Right? Or am I wrong? Because what does this do? Decrypt. Hang on. It's right here. You know what? Let's do, foo@bar.com, hexob, 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 hexob. Encrypt does take bytes. Okay, good. I've been screwing that up all along anyway. What is wrong with you? Oracle.encrypt. No, it takes a string. I guess that should be taking bytes instead, right? What's going on? What's going on? Get rid of that. That's going to blow up anyway because that's bad times, I think. Oh no. Hexob, oh no, that is valid ASCII. Became that. Not good, not good, not good. At least I don't think that's good. Pretty sure we have to use this block divider here with the equals landing right before it, because we can't bring equalses to the party. So we can't have it be butting up against the end of a block because admin is less than 16 bytes long, so it can't be made to butt up against the end. URL encode. I think Wolf was saying it takes a safe. Yeah, so that worked. But also feels bad putting binary in the email if email is a string. But then again, everything less than hex 16 is ASCII safe. I've got a feeling these challenges kind of predate Python 3. Then again, they're not Python focused anyway, so our choice of Python is our own mistake to live with. Do we just go and add like everything except for equals and ampersand to safe? It feels gross, but I think we have to. Unless I'm missing something, I think we have to let hex B or whatever be safe. Yeah, let's. So safe is going to be safe takes string, doesn't it? Bytes or string. Okay. We'll just do bytes over. Can you do bytes over range 128? Bytes range 128. Yeah, there we go. That gives us all the ASCII safe characters, which feels gross to be using as though they're bytes. Like it's the old Python 2 way of just YOLOing bytes around, but we shouldn't need anything above 128 anyway, so... Anyway, let's just run our tests and see what we just broke. Oh no, the at. Yeah, the at, that's fine. I'm okay with the at there. But here's another test that broke, because we were told that we're not allowed to let people bring equals and ampersand to the party. Let's do a regular URL encode over equals ampersand %3D %26. We do expect to get those for these two particular nasty characters. And if we run the tests, that test will fail because we're letting people use them. So bytes B for B in range 128 if B not in ord of ampersand and ord of equals. So they remain banned. Tests pass. So equals and ampersand are being hex encoded, percent encoded, but hex OB we should still be allowed to use hex OB. It comes out as ASCII, which is like some, I think hex OB is that tab. OB vertical tab. Which feels bad, man, but I think it makes things exploitable. So we'll leave. I think that's the spirit of the challenge. I think it wants you to be able to use padding bytes. So now if we rerun main, foo@bar and then a bunch of B's becomes email equals foo@bar.com, and then there's our B's. So we should be okay now. We've got the oracle, we've got the ciphertext and plain text. Let's just comment those out for now. Block one. Block one is going to be space times block size minus the length of email equals. So that gives us these spaces. Gives us these spaces here, I think. Block size minus the length of email equals. I could very well have an off by one there, but I think it gives us that many spaces. Then block two, so the role we want to be admin. Block two is going to be role plus the chur of block size minus the length of role, which I think is hex OB. Role plus chur block size minus, I think we're good, times block size minus the length of role. So it's going to be like hex OB times hex OB, like character hex OB times OX0B. That's block two. So now ciphertext is going to be the oracle over oracle.encrypt over block one plus block two. And let's just run that and see what debugging we get. So we're encrypting spaces and then admin and then that. Let's pinch that. Come on. And I realize that these spaces are turning into pluses, but I don't think it really matters because we're going to be throwing away block one anyway. There we go. Oh, I missed a space. Anyway, let's put that space back in here. Email equals space paste. Yep, that looks like it's lining up. And then that looks like it's looking like PKCS padding to me. Should be 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. So block role is going to be chunkify, which we need to pull in. It's going to be the list of chunkify over the ciphertext, with the chunk size being block size. I'm going to grab the second block out of it because it's the one that has all this stuff having been encrypted. So the role block is going to be that. Now I'm going to cheat again. I'm going to print decrypt of the block role with the key being oracle.key. So I'm going to borrow Oracle's key for a moment just to see if we're on the right track here. That looks pretty damn good to me. It even unpadded it for us, and it unpadded cleanly, and we just get admin. Okay, so we've now got a block that contains admin and then sufficient padding for it to be the last block in some ciphertext. So now we need to do this one here, where we basically have enough padding here so that role equals finishes a block. I'm gonna yoink that. Oh, come on. For I in itertools.count 1, so start counting from 1 and keep going forever. Pull in itertools. Pull in itertools, good. For I in itertools.count, if the length of email equals plus space times I plus UID ampersand UID equals 10 ampersand role equals, if that's a multiple of block size, we break. So if length of that mod block size equals 0, break. And then I is a terrible name for a variable. How do I refactor? I forgot my keyboard shortcut. I'm in the wrong file now. Is it this? Yeah, good. For padding length in that, counting, email plus space times padding length plus that mod block size. Yep, good. Break. Good. So now we want to do ciphertext equals oracle.encrypt over space times padding length. It's going to give us something that looks like this, with that equals being right on a block boundary. So then we just replace the last block, which is just a block that says user, with the block that says admin, and we should be good. I meant to do that. Yep, good. Why are you yellow? It's not referenced before assignment. It got referenced like assigned 4 lines above you. Goodness gracious. Padding length equals none. Shut up, linter. Now you know what, I'm going to leave it yellow. It's fine. So now winning ciphertext equals the ciphertext except for the last block plus, I don't like block role, that should be block admin. So ciphertext everything but the last block. Nope, we need to chunkify ciphertext. Oh goodness. Okay. List of chunkify of ciphertext with a block size of block size. Everything except for the last block. And then we need to stitch it back together. Empty bytes.join. The winning ciphertext is everything with the last block plus the block that says admin. So then we do role equals oracle.decrypt over the winning ciphertext and print role, and hopefully it's admin. Easy peasy. once we made it winnable. Clean up some of this debugging stuff. We can make our oracle not be verbose anymore. So we've got block 1, which is just enough padding to take us out to the next block size. Role is admin. Block 2 is just admin and then appropriate padding. We smash them together and encrypt them. We grab the second block, because that's the one that says admin, and we stash as block admin. We calculate the length of the padding needed to take role equals out to a multiple of the block size. Encrypt our padding. Strip off the last block and stitch on the admin block and get the role after decrypting, and away we go. Cool. Now we've just got to wrap that up in a function, write a test, and we are golden. So let's define a function that is craft profile CT using ECB cut and paste. What an awful, awful function name. The role is a string, and it's going to return bytes, I'm pretty sure. No, this also needs to take an oracle, which is a callable. And the callable takes string and returns bytes. Right? Oracle.encrypt takes string, returns bytes. Good. Yoink all of that. Put it there. So now the oracle in this context is a callable that does the encryption. So we don't need to do oracle.encrypt. All we do at the end is return winning ciphertext. These two belong in main. Yoink splat. So the oracle is a profile oracle. The profile is going to be craft profile CT using ECB cut and paste, with the oracle being oracle.encrypt. And the role is admin. It's a string, right? Yeah, it's a string. Oh, that role is not used. We can get rid of role equals admin, and we're already using the word role all throughout here. We've got no admin, so we're good. So this function actually, it doesn't need to just create a profile for admin. It can do it for any role actually. So the profile is going to be craft the profile ciphertext using cut and paste. Oracle is oracle.encrypt. Role is admin. So then role is going to be oracle.decrypt over the profile. then we're going to get print roll is going to be roll bang R. That's just a bit of refactoring and tidying. Run it. Error. Function has no attribute encrypt. So oracle.encrypt is not needed. We just do oracle because in this context, the oracle is the encryption function. There we go. Role is admin. Yoink these, turn them into a test, and we are done. So the oracle's a profile oracle. Profile is going to be that awful. Should we rename this? That's kind of messy. Let's just craft profile CT. I don't think we'll be lifting this function into utilities. I think it's a one and done function, this one. So the profile is going to be to craft the profile ciphertext with the oracle being oracle.encrypt. That's good. The role, don't need spaces there. Did I pinch that from here? No, I did not. Hang on, what's going on? Profiles, craft profile ciphertext, oracle equals oracle encrypt. That's good. This here, I don't know what happened there. Role is admin, and then oracle.decrypt over the profile should give us admin. Is that right? Oracle is the oracle. Profile is going to be crafted. Oracle is the .encrypt. Role is admin. Oracle.decrypt the profile. Returns the role, which should be admin. Run the tests. And it did not pass. Oracle. These three greater thans don't need to be there. Phew. I was getting worried for a second there. Alright, test pass. And we are done with ECB cut and paste. And I deleted my little picture of what was going on, but hopefully that made sense. I'm going to take a short break. You should do the same. Stretch your legs, get some water, stay hydrated, get yourself a snack, and I'll see you on the other side of this short break. Bye for now. Well, not bye for now, but I'll see you soon. Alrighty, we are back. I got enough gas in the tank for another one, but we'll see how we go. Challenge 14, Byte-at-a-time ECB decryption harder. Maybe I don't have gas in the tank, but we'll see. Alright, take your oracle function from number 12. That's good. Good we didn't send that one off to utilities. Now generate a random count of random bytes and prepend it to every plain text. Ooh. So the oracle looks like AES 128 ECB with a random prefix, so random length of random bytes. Then it's the attacker control data. Then it's the flag. Decrypt the target bytes or the flag. Now, I'm guessing that the oracle should use the same key between encryptions, and it should also use the same random prefix between encryptions. Yeah, prepend this string to every plain text, so it's not a fresh random bytes every time. Stop and think for a second. You see, thinking for a second, a couple hours of programming saves thinking for a second, but sure, I'll listen. How is this harder than challenge 12? How would you overcome that obstacle? You're using all the tools you already have. No crazy math is required. Think stimulus and response. Well, that's a super cryptic challenge, isn't it? Yoink. And we get a new challenge. Menstrual. Good to have you here, my friend. Welcome. I misnamed that file. Here I am thinking I'm on set 3. Look at me. That should be set 2, challenge 13. And this one here is, you know what? I'm going to duplicate this file here. And PyCharm's going to yell at us a lot for a while because of the duplicated code. Byte-at-a-time ECB harder. Is it harder or hard? Harder. Alrighty. So now the first thing we need to do is obviously hack up that oracle. Well, actually, the first thing we need to do is copy the challenge text. So class AES128 ECB append and encrypt oracle. This class name's gonna get out of hand as well. No, I'm not going to rename the class, actually. I don't think I will. But the initializer is going to take a suffix of bytes, which is the flag, but it's also going to take prepend junk, which is a boolean of false by default. Junk is bytes. The initializer is always going to prepend the junk, but in the encrypt, that's when we'll actually decide whether to prepend it or not. Menstrual, I don't want to hear make fun of one of my long. Nah, I'm going to do it anyway. It's too much fun, dude. It's just too much fun. Self.junk is, do I have token bytes? I do. The number of bytes has to be random as well, right? I liked the previous challenge where it was asking us to do between 5 and 10 random bytes. I think that sits nicely in that sweet spot of it's a 16 byte block. So if we added like multiple blocks of junk, I would just, it's ECB, so as an attacker, we just throw them away anyway. So between 5 and 10 random bytes. What does secrets give us? Is it rand below? Yeah, rand below. So the token bytes is going to be 5 plus rand below of the exclusive upper bound, so 6. Because rand below gives us between 0 and 5. 5 and 0 is 5, 5 and 5 is 10. So self.junk is between 5 and 10 random bytes. Encrypt. Oh, we've got to stash this prepend junk. So prepend junk is a bool. Self.prepend junk equals prepend junk. No. If prepend junk, self.junk is that, else self.junk is empty. Oh, I completely screwed up that signature. Prepend junk is a bool and it is false. Goodness gracious me. Okay, so now in the encrypt, we can always prepend it with self. We can always prepend it with self.junk. And the prefix, which is this user controlled. It's not really a prefix anymore, is it? Doesn't matter, we're calling it a prefix. The encrypt is going to do self.junk plus the prefix plus the flag over with the key. And then in the default case of this oracle, prepend junk will be false. Hence, if this will get taken, and self.junk is empty. So there's no real change. But if prepend junk gets set to true, we actually generate the junk to be appended here. Cool. Oh, this is actually one thing. When I was editing the video for last stream, I didn't like this word leak. Really, that's more of a discover. So I'll make that change now. Same thing here. Oop. The Vault 1999. Junk bytes is all bytes before attacker controlled. Then it can be truly random. I don't understand what you're suggesting or asking there, the Vault. Junk bytes is all bytes before attacker control. I'm sorry, I'm not understanding. If you can rephrase, I can try again. Discover the block size and the suffix length. I think our suffix length calculation here is going to break with the junk. Random bytes you need to prepend. We're not prepending. We're not. Oh, we are prepending. Yeah, we're prepending. The bytes are given by token bytes, which is a function that generates random bytes. We just grab this, jump to a REPL, and we import secrets. This is what it looks like. So it's varying lengths between 5 and 10. Does that help the Vault? This is what our junk is going to look like. It's going to be different for each oracle, but each oracle is always going to have the same junk each time you call it. I think that's the goal here. Generate a random count of random bytes and prepend it to every plain text. So it goes at the beginning here. I hope that clears up whatever's on your mind. So we've fixed our oracle. Now, assuming the random prefix is less than a block's worth, and we can actually prove that. I think we can have an assertion that froze, if not an assertion. We can check that holds. But if this is less than a block length, we can discover its length by basically adding how about this? Because discover the... Let's duplicate this test case, yank 3 down, and have this oracle prepend junk equals true. And the suffix is going to be 8As. And we expect to get back 16 for the block size and 8 for the suffix length. Should this function also, because this function can figure out how long the prefix is as well. But I know if I rename this function to include the fact that it's going to find the prefix length, if I just said suffix length, I'm sorry, the junk length. If I rename this to include the fact that it's going to find the junk length, the Menstrual's going to laugh. And we can't have that. It's gotten to the point where we need to rename this function. Because I can deal with this, but I can't deal with it any longer. Let's just call it. Let's call it. Oops, no. Let's call it interrogate appending oracle. And I don't like this tuple anymore. We need a named tuple because it's getting out of hand. So let's pull in our named tuple. How does one name a tuple? I think it's a class. Class interrogation is a named tuple. and it has a block size of, we just got to give them labels. Block size, it's going to give us suffix length, and it's going to give us block size. Let's go block size, junk length, and suffix length. That way it's kind of left to right. Junk. Do we have a better name for junk? Do we call it prefix and rename our prefix to something else? Nah, because junk's random. Prefix is attacker controlled. Suffix is flag. Yeah, it's fine. It's fine. So this function no longer returns a tuple of int, it returns an interrogation. And the junk length is going to be 0 in the general case. Oop, we need to interrogation with the block size being block size, junk length being 0, and the suffix length being suffix length. And we'll fix this in a moment, and everything else needs to be fixed. Let's run the tests and watch things break. No tests were found. How did I just break my tests? Class interrogation name tuple. How did I break my name tuple? Oh, they're not classes at all. Oh, goodness gracious. I wrote them as if they were an enum. Okay. Point equals name tuple point xy. Yeah. And I don't want a data class because data classes are harder to unpack. Interrogation is a named tuple called interrogation. That looks a bit healthier. Nope, it does not look healthier. We need to quote these. What a mess. There we go. Run the tests. Yeah, these are wrong now. Why are you yellow? Oh, not yellow anymore. Good. Yep, that's actually correct for this case. The block size is indeed 16, the junk length is indeed 0, and the suffix length is indeed 8. This one here is the same, but the suffix length is 24. And let's just have this one return. Oh goodness. This one's a bit trickier. We're going to have to do this. We're going to have to actually unpack this result. Block size, junk length, suffix length equals that. Block size is equal to 16 is true. Junk length is equal to the oracle.junk, the len of it, that has to be true, and the suffix len has to be equal to the length of suffix. That has to come back as true. So those three things have to hold for this last test case, because the oracle junk can be of varying length. Run these tests and that one will break. So junk length is length of oracle.junk. We expected true, got false. That's expected. Suffix length is the length of suffix. Suffix len is not defined. How did I screw that up? Okay, let's rerun. Yeah, we expected that one to fail. We also expected the suffix length to probably fail. Block size, suffix len equals... Oh yeah, and so now everywhere we're using this, we have to update the usage. Which is apparently just here. It's going to be block size, junk len, suffix len. Rerun the tests. Yep, okay, so we just gotta, okay, so right now this is a focus. We need to fix this function here to properly calculate block size, junk length, and suffix length in the face of prefixed junk. Let's spend a minute and think about how we're going to do that. The block size is always going to be fine, because to calculate that we're basically just adding more and more characters until the size changes, and as soon as the size changes it means a whole new block's been added, so the block size is fine. This calculation for the suffix length is also fine if we subtract the junk length, which we still need to calculate. So we start off with junk len equals 0, and this will still hold for the first two cases. So we don't need to fix the block size or the suffix length for either. Sorry, we don't need to fix the block size for any case. The suffix length, as long as we subtract the junk length, as long as we calculate and then subtract it from this, it's also going to work for all cases. We just need to calculate the length of the junk. And we want to do as much of this as possible in a way that remains compatible with our previous solution, because then whether we have an oracle with prepend junk is true or prepend junk is false, it'd be really nice to have a solving function that takes an oracle that works for both cases. That'd be a really nice function to have. We can calculate the junk like this. Block equals, you know what? I was going to generate a block of random noise, but to do that we need to know the block size. That's fine. We can do block size equals that and then break. Return none for now, just to kind of make this dead code. The block is going to be token bytes for block size, a whole block of random noise of length, block size, which we just calculated. So now what we can do is we can basically do this. For j in itertools.count from 0 onwards, we can do oracle of z times j, so 0 z's, 1 z, 2 z, 3 z's, 4 z's, 5 z's, and so on, plus block times 2. So ciphertext is that. And then CT chunked is going to be chunkify CT to the block size. And then if CT chunked 1 equals CT chunked 2, hang on, hold on, not quite, close but not quite. I'm basically going to be just like adding padding until 2 identical blocks appear, and then however much padding I had to add, I can subtract that from block size to know how much junk there was on the start. But for the first time through this loop with 0 padding, I want to compare CT chunked 0 with CT chunked 1, but then every other time through it, I need to compare 1 against 2. Oh, what a mess. Okay, how about we break this out? Test the case where there is no padding. Ciphertext is going to be just block times 2, chunk it. If CT chunked 0, I have to list this out. If CT chunked 0 equals CT chunked 1, first 2 blocks of CT are identical, thus there was no prepended junk. So not padding, prepended junk. Test the case where there's no prepended junk. Chuck 2 of the same block at it, and if the first 2 blocks come back identical, we're good. And we can return an interrogation of block size equals block size, junk length equals 0, and suffix length equals yuck. Suffix length is actually junk. It's actually junk and suffix length. Get rid of the minus junk length. Whoops. And get rid of junk len equals 0. Junk and suffix len. In the case that there was no prepended junk, the suffix length is the junk and suffix len. I don't love returning early like this. Instead, I'm going to do this. I'm going to go junk length equals 0. And then else we're going to pass. At the very end here, we can do this. Junk length equals junk len. And suffix length equals junk and suffix len minus junk len. And with this being 0 here, that's going to work for kind of the base case. These lines go in the else condition. First 2 blocks of CT are different, thus there was prepended junk. So now we start counting from 1. For J in intertools.count from 1, do JZs and then our 2 blocks, chunk it. We have to list it out here. And then if block 1 equals block 2, which is the second and third block are identical, then junk len equals block size minus j. And we're assuming that junk length, hang on. This function will basically never return if the junk is more than a block long. We can probably make it work in the case that junk's more than a block long anyway. Oh, my mouse. I thought I fixed my mouse, but it's misbehaving again. We can probably figure out how to make it work for we can make it. Do we want to bother though? Are we overdoing it? Look, you know what? I'm going to take a quick 5-minute break to stretch my legs, grab a glass of water. You should do the same. When we get back, I want to have a think about if we should bother making this work in the case that this junk here is more than a block's worth. I think we can do it, but it's just introducing fragility. I mean, I'm inclined to do it, but well, let's have a think. I'm going to take a quick break. I'll be back in a moment to keep making a real mess of things, and I will catch you then. Alrighty, we are back. And I'm inclined to do this the hard way, because we weren't told how many random bytes to add. We weren't told to add less than a block. And so I'm inclined to do things by the letter of the challenge and have it work for more than a block. In which case, maybe we want to have our oracle be parameterizable. To make it testable. So let's quickly do that. Instead of prepend junk bool equals false, let's have a parameter which is prepended junk is a tuple of int. And by default, it's 0, 0. So minimum length of 0 prepended junk bytes, maximum length of 0 prepended junk bytes. So instead of that and that and that, the junk is going to be token bytes of prepended junk. Let's unpack it. Junk min junk max equals prepended junk. So we'll unpack the tuple, and then we'll go junk min is the minimum number of junk bytes. And junk max minus junk min is the maximum? Is that right? If we pinch this, junk min is 0 and junk max is 0. From secrets, we'll pull in token bytes. And we'll pull in rand below. Upper bound must be positive. +1. Okay, so that's always empty bytes. If we had a junk min of 0 and a junk max of 1, then we either get 0 or 1 bytes. That looks reasonable to me. If we had a max of 2 and a junk min of 1, yeah, then we always get either 1 or 2. 1 or 2, 1 or 2, 1 or 2. So that there is our junk generator. Meeps or F or just my internet? Let me check my link seems good. I have no dropped frames. I think it might just be you, Meeps or. If anyone else is having issues, let me know. But otherwise, Meeps or, may I suggest you refresh and try again? Because I don't think it's me. Why are you red and angry? There we go, it's better. We probably should, if junk min is less than 0 or if junk min is less than 0, raise value error, junk min must be greater than or equal to 0. And then if junk max is less than junk min, raise value error, junk max must be greater than or equal to junk min. Okay, so just some checking on those values. And I think that's a good way to generate the junk in a way that we can then do good testing. Cool. So this doesn't make sense. This prepend junk makes no sense. It's now got to be prepended junk equals, I don't like that label, prepended junk min max, prepended junk min max is going to be between 5 and 10, and then we'll do it again. It's getting a bit ugly. We'll do it again for prepended junk min max being between 40 and 60. So that'll really stress it. Those tests are getting out of hand, but it is what it is. Okay, so now it's testable. The case where there's no prepended junk is still fine. Why are you yellow? Might be referenced before. It can't be referenced before assignment. You know what, you're staying yellow as well, I don't care. Yeah, because that can't be unassigned, because block size has to be set before this breaks. PyCharm just doesn't know that this is an infinite loop. So no prepended junks should still be fine. Yeah. So if the first two blocks are different, then there's prepended junk, and this is where stuff starts to matter. So for J in initools.count of 1, ciphertext is going to be JZs and 2 blocks. You can define block size before the loop. I know I can the morph, but I mean, I know I can do stuff like this, block size equals none. And it makes it go away, but that's super important if you're programming in C. I realize you should never use a potentially undefined value. But I'm kind of sick of doing it just to appease the linter, because it looks ugly. I know the yellow looks ugly, but that looks even more ugly. Surely there's a way to actually like ignore. Actually, can we just ignore this? I'm sure there's a way to like tell the linter that that can't happen, but anyway, it's fine. We all know what's going on. So for J in count from 1, I'm going to have JZs and then the 2 blocks, and we're going to then chunkify it. And I no longer want to count on these two being the same. Actually, you know what? We can probably collapse this down now. We probably don't need this base case test. You know what? I'm going to assume we don't need it. And if we need it, we can rewrite it. So let's actually just comment this out. I don't think we're going to need this anymore. Oh, come on. It's not what I wanted. There we go. Dedent that and start counting from 0. So I've got a plan. Ciphertext is going to be JZs and then 2 blocks, 2 identical blocks. We're going to chunkify it on the block size. And instead of checking these two, we're going to pairwise them and look for a match. My Python doesn't have pairwise, so I'm going to get the old polyfill. There it is. Oh, this mouse. It's better. I say that and then screw up the mouse again. I have made some effort to fix this mouse. It is behaving more, but it's still not perfect. Wolf, time to update Python. Yeah, we'll be here till 1 AM. There's our pairwise. How do I redock? There we go, dock. Thank you. Now I've got a plan, but I want to know, can I enumerate a pairwise? So I'll pull in editor tools to our REPL. Editor tools. Grab that, plonk it there. So now let's do a pairwise over range 10 and then list it out. That pairwise works. So basically like yields each pairwise pair. So 0 and 1, 1 and 2, 2 and 3, 3 and 4, 4 and 5, all the way up to 8 and 9. Now, can I enumerate a pairwise and then list that out? Yeah, so that basically gives me the index, the value, the index, the value, the index, the value. So I can now do for I, can I do this? For I, J, K, in that. And then we can go print I, and go print J and K. Yeah, so we get 0, 0 and 1, 1, 1 and 2, 2, 2 and 3. So we can kind of count our way through the pairwise pairs. 0, 1, 2, 3, 4, 5, 6. And we can also get each of the two values. And we can then check them if those chunks are equal. So yeah, enumerate pairwise works, and it works exactly how I wanted it to work. So this is all still fine. So we chunk it. So now we do for I. Actually, did I even need I? I did. For I, chunk 1, chunk 2 in enumerate pairwise CT chunked. Oh, C1, C2. If C1 is equal to C2, handle it. One other thing I realized when I was taking a break, we actually don't need to do itertools.count. We don't need to count forever. We only need to count up to the block size. range of block size. Because if adding, like let's say the block size is 16, if adding 15 Zs doesn't give us two identical chunks somewhere, there's no amount of Zs we can add to cause the two identical blocks, this block times two, there's nothing we can do to cause them to align. They will never align if it doesn't happen before block size number of Zs. So we encrypt, we chunk, we enumerate the pairwise for I, C1, C2. C1 equals C. If C1 is equal to C2, we've managed to block align our two blocks. Or there is otherwise some adjacent block redundancy. Keep in mind that the oracle, whoops, I screwed that up there, min max, good. Keep in mind that the oracle has a flag buried within it, right? This thing called suffix, that it's actually tacking onto each encryption. If there's two blocks in that are identical, we don't want to spot those pairwise as being our two blocks that we've introduced. We need to skip over those cases, which we can do. Check for the two block. Check to see that the pairwise block redundancy was not caused by redundancy in the suffix, in the oracle suffix. We can do this. What we need to do is basically repeat this. Except instead of block times 2, in fact, Z times J feels a bit dangerous as well. I don't like all these Zs. They could be causing problems. Be better if that was just noise. Padding equals token bytes over J. Let's just call this padding. So rather than Zs, we've got noise. And in here, what we really want to do is we just want to replace all of this with noise. So the oracle over token bytes of J plus block size times 2 basically replaces all of this with just noise. And now we want to check to see that this no longer would have held. Because if it no longer would have held, it's probably us that caused it. And there's probably edge cases still where it wasn't us. Goodness gracious me. I hope we're getting real, like, win the lottery edge casey in those cases, but we're... Let me have a think. To do check that we no longer got the redundancy. Do we want to do this, or do we want to just subtly break what we were sending? It probably doesn't make a difference, does it? It doesn't make a difference. Look, I'm gonna forge ahead, and we can just keep in the back of our minds that this is potentially brittle, but I think it's like edge case, like a very rare edge case anyway. Yeah, to have, like, by luck gotten two blocks identical that we're not about to break, surely that's like buy a lotto ticket chance. Surely Yeah, it's got to be. So now we can just use I think. If ct chunked of I is not equal to ct chunked of I plus 1, confirmed. We now know that the junk len is equal to block size times I plus j. And I've totally got these i's and j's backwards. So I'm going to refactor this I to be I. This one can now safely become I, and this one can become j. And here we can break. Oh, we gotta like break two. Oh no, hang on. We're in like the bad double loop, trying to break out of a double loop case now. I in the range of block size. Yep, we are in the awful case. Which I think means we're meant to put this inside a function. Yep, we are. Let's define get junk len, and it needs to be given. Oh, yuck. What do we need to pass to this function? Oracle is a callable, which takes bytes and gives bytes, I think. Needs a block size, which is an integer. That's all we need to pass in. Indent all of this. Can we delete this? What was this from? Yeah, we can delete that. That's gone. We can just return this. This returns an integer. If we finish this loop and we haven't returned, we just need to raise something. Can we like raise this? What is a runtime? Let's do raise Python exceptions. What do we raise? You know what? I'm just going to YOLO raise an exception. I don't even care at this point. Raise exception. Failed to determine junk len. Junk len equals get junk len given the oracle and the block size. Why are you yellow? Again, it's a reference before assignment, but it can't be unreferenced. I think we're good. Need some cleanup, but do the tests pass? Nope, they blow right up. Unexpected indent. Let's just clean, let's just dedent it for now. Run the tests. Oh, please work. Nope, of course it didn't. Junk length was wrong. Suffix length was wrong. Let's set a breakpoint here and debug our tests. Junk len came back as 0, which is probably fine because this oracle probably doesn't have junk. Why are you not showing me what's inside the oracle? Please and thank you. Oh, because it's... Hang on. Here it is. Yeah, junk is empty. So that one's fine. So we continue. Here we've got junk len is 0. It is 0. That one's fine. Here we've got junk len is 0. Junk is empty. That's fine. Here we've got junk len is 0. And we've got empty junk. That's fine. How many of these am I doing? Here we've got junk length is 22. Junk is actually 10. So we are wrong. But 10 and 22 is 32, which is a nice round number. Is the junk length block size times j plus I? No. It's block size times j plus block size minus I. Because we've got junk, which up until the jth block was all junk, that's fine. And then this bit of junk here is the remainder after the block size has the padding subtracted. Okay, I think we're good. Run the tests. No, don't debug them, because it takes forever. Remove the breakpoint, run the tests. Now I've got 2 failures. And now we're, saying that does this need to be block size times j minus 1? Because we're over by 16. Or do we just need to subtract the block size somewhere? Let's draw some pictures. So if we've got no junk, then we would have needed to have 0 padding, and then the block and the block would have matched in the base case. So the base case, I is 0, J is 0, C1 and C2 are equal, so this hits. This would have taken this branch. Block size times J. J is 0, so that's 0 plus. Block size is 16 minus I, and I was 0. Do we just subtract a block size from here and we're good? Run the tests. Ah, thank you, Jesus. We're done. We're done. Let's yeet some of this nonsense away. Get rid of this. Okay, so we've now got a function that interrogates the appending oracle, and it gives us an interrogation, and these tests pass. So now we've given an oracle, whether it's got 0 padding bytes at the beginning, or even more than a block's worth. We can discover the block size, the junk length, and the suffix length. Good. So now we've got to leak the suffix. This test case will hopefully still pass. We'll add a new test case. Yank 5 down. Flag's going to be that. In fact, we don't need to redefine the flag. The oracle is going to have some junk. Prepended junk min-max is going to be between 5 and 10. We want to leak the suffix. And the suffix has to be the flag, has to be true. That test, we want that to hold. yank again, put. The min-max is now going to be between 40 and 60 junk bytes at the beginning, and we still want it to hold. Okay, so we've got our tests for the new annoying oracle that prepends junk. Good. We don't need this comment anymore. It's pretty self-explanatory. We're getting the block size, the junk length, and the suffix length from this interrogation function, which we know passes its tests. Now, prove it's ECB, bail if it's not. This fails to detect the case where the oracle prepends junk, which starts with... Okay, so this test we wrote last time to prove it's ECB was predicated on... the first two blocks being comparable. But I've got a feeling that this function here, interrogate, if it's not ECB, I think this exception is going to raise, because you're never going to see this hold, and that will only hold if it's an ECB mode block cipher. So recall that challenge 12 wanted us to detect that the function is using ECB. You already know it, but do it anyway. All right. I think we can safely say that this function will raise an exception if it's not ECB. In which case, can we raise a value error? Does that make more sense? Failed to determine junk length. Oracle probably isn't ECB. And I just want to delete this now because it's kind of redundant at this point. So, yeet, you're gone. Now, our aligning chunk. It's going to be Z times the block size minus... my brain's breaking. We should be fine. Like, I think we've just in a few places got to pepper in some, like, subtract the junk length. Maybe. Either way, I'm starting to get a little bit fuzzy, so I'm going to take a quick 5-minute breather to stretch my legs and try and refresh the brain so that we can plow through the rest of this, because I really don't want to be stopping at this point and having to pick up at this point next stream. So bear with me while I take a quick break, and when we get back, let's see if we can polish this off, hey? Speak to you on the other side. Alrighty, we are back. Let's see if we can get this done, hey? So we've now got this, this extra junk length. So the aligning chunk is going to be up a bunch of Zs to basically tack onto the end of the junk. So we start... Hang on. No, the aligning chunk is to have the suffix start on a block boundary. And we've got a friendly assertion from last time to make sure we don't screw it up. We want to assert that that adding just another byte, no, subtracting a byte from the aligning chunk causes it to drop by a block size. We need to have this equality hold. So like if we just run the test, that assertion probably gets raised. Yeah, aligning chunk length is wrong. What a lovely assertion. How many Zs do we want to have it start on a new block? Do we just add junk len to the suffix len? Feel like it's at least worth trying. We do have an assertion to catch us if we screw up. Yep. So this assertion is now holding. So I think we can just move on. I think that we've now proven that we've basically aligned our suffix on a block boundary. No, we haven't aligned our suffix on a block boundary. We've aligned the entire plain text to a block boundary. That's what we've done, yeah. So then we're creating a suffix, which is a double-ended list or a dec for I in the range of 1 through the suffix len plus 1. So for each character in the suffix length, we're running the oracle over our aligning chunk and IZs to kind of push an extra character of the suffix into the stream of the last block. The last chunk, we chunkify the ciphertext to the block size. Oh man, I really would have thought this would get more than no bytes. What is the length of our aligning chunk? You know what, let's set a... this is gross. If junk length is not 0, let's print 1, just so we can set a breakpoint on it and run the debugger. How long is this aligning chunk? Because if it's like more than a block's worth, then 14 bytes. That sounds reasonable. So we've got 8 junk bytes. That's not unreasonable. Okay, so we've got 14 Zs. That assertion holds. For I in the range of 1 through the suffix length plus 1, that's fine. Ciphertext is the oracle over the aligning chunk and IZs, which should be, yeah, pushing 1 byte of the suffix, the last byte of the suffix, into a new block. Into the last block, I should say. Last chunk is... we're using chunk 0 here to do our brute force in. That's bad. Because our first block's probably full of... It's got some padding in it. Cool. Nah, I'm good now. We can stop this debug. We don't need that anymore. So it's this here. This 0 is bad. So our aligning chunk, that's fine. We need another aligning chunk, basically. Exhaust, padding, exhaust, junk is going to be the junk length mod the block size. No, it's going to be the block size minus that. So if we do padding exhaust junk, actually, you know what? We can do this. Z. No, let's do Y. Something different. Y times that. So now padding exhaust junk is basically going to it's a bit wasteful in the case of no junk, but it's fine. It's fine. Why you've got a yellow underline? Duplicated code fragment, that's fine. So the plain text is not going to start with B. It's going to start with padding to exhaust the junk. That's not okay. That's not okay. Because we can't have a bytes inside that list. Kind of gross, we'll just put it here. Padding to exhaust the junk. Goes there. So we're gonna exhaust the junk, but then this 0 needs to change. This 0 needs to be, In the case of junk length being 0, 0 mod the block size is 0. Block size minus 0, we're going to have a whole block of y. In the case of junk length being 1, 1 mod block size is 1. Block size minus 1 is 15. In that case, we do need 15 y's. So, okay. In the case of no junk, we'll have a block of y's here, but that's fine. It's whatever. In the case of block size being 0, this needs to be 1. In the case of block size being 1, it also needs to be 1. Sorry, in the case of junk length being 1, this also needs to be 1. In the case of junk length being 15, this also needs to be 1. Junk length being 16. Mod 16 is 0, right? Yeah. 16 mod 16 is 0. Block size minus 0 is block size. If junk length is 16, if it's 0 or 16, this still needs to be 1. But if junk length is 17, this needs to be 2. Yeah. 17 needs to be 2. Yep. So 17 needs to go to 2. 16 needs to go to 1. 0 needs to go to 1. Yuck. Yuck, yuck. How do we express this? 17 mod 16 is 1. That plus 1 is 2. Good. 16 mod 16 is plus 1 is 1. 0 mod 16 plus 1 is 1. 1, 1. Good. Junk length mod 16 plus 1. So this needs to be junk length mod block size plus 1 to basically get along to the block that's actually going to have our brute force happening within. And then are we good? Run the tests? Nah. It got up to empty string. Fantastic. Of course it wasn't going to be that easy. I'm going to set a breakpoint in here. If junk length is not 0, print 1, just so we can break. Plain text. Why are you 26 bytes? That feels weird. 26 bytes. Oh, hang on. Junk length is 6. 26 and 6 is 32. So I'm okay with that. 6 bytes of junk. That's probably going to be 10 Ys there. Yeah. Ys, there's 10 bytes of them. 6 and 10 is 16. Good. Then we've got 0. And then 15, 15. So that's good. Junk length mod block size plus 1. 6 mod 16 plus 1 is 1. And I should be looking at block number 1. So why is this not working? Because Oracle has 6 bytes of junk. That's fine. 6 bytes of junk, and that 6 and 10 Ys is 16. That finishes a block. Then we've got the null byte, then our Fs. Junklen is 6 mod. 6 mod 16 plus 1 should be 1. 6 mod 16 plus 1. Hang on. What? Zero mod 16. Okay, I've completely buggered this up. Alright, well at least we know that this was never going to work. I was just picking numbers that worked. What about... Because yeah, 17 needs to go to 2, 16 goes to 1, 0 goes to 1. So just... Not mod, do I do 0 / / 16 plus 1? That's 1, good. That's 1, good. That's 1, good. No, that's bad. Oh, yuck. This is getting really gross. I'm so sorry. So this has to be, I think... Junklen -1 over the block size +1? Probably not. Probably not. 1 - 1, good. But 0 also needs to go to 1. And that breaks. Our 0 special case might be killing us here. Padding exhaust junk. If junk length is 0, maybe we just need to have padding exhaust junk be empty string. If Junklen is 0, padding exhaust junk is empty string, empty bytes, else this special case because we've made a mess. Yeet yeet. Do our tests now magically pass because we've handled our special case? Wow. I can't believe that works. I'm very, very skeptical that it's working properly, but it got us our tests passing. I mean, let's do a bit of a more substantial test. So def main, Oracle's gonna have prepended junk min max of, let's go 0 0 for now. Let's have a prepended junk min max, so the minimum of 0 and a maximum of 1024 kilobyte of junk. Whew, that's a lot of junk. For underscore in range, let's do like 100 tests. Assert res is equal to flag. Oops. This is just a much more exhaustive test. Let's run main. It's not throwing. And then it throws. Makes sense. How often does it throw? Pretty quickly. Oh, it's on a run. It's on a tear now. This is the worst kind of error to fix. It's intermittently failing, and I'm unhappy. Oh boy. Is it failing when like the junk is a multiple of the block size or something? You know what? For iron range 100, let's have the min-max be II. Excuse me? Oh, we're not printing I anymore. That makes sense. Okay, so failing on 16, that's kind of, I'm okay with that. It's probably something in this awfulness. Because 16 had to go to 1. So 16 minus 1 divided by 16 plus 1. No, that makes sense. Yeah, we've got a different failure at junk length being 16. Let's just, I just need to be sure of this. Print the length of oracle.junk. Oops. So yeah, when Oracle has 16 bytes of junk, we blow up. Basically, this loop doesn't win. So let's sixteen. Run. Blows up straight away, good. So it's in here. Let's just set a breakpoint on this loop. We'll just have a quick squiz to see if anything looks off. So the junk length is 16. That makes sense. The block size is 16. That makes sense. The suffix length 138. That rings a bell. Padding to exhaust the junk is 16 wise. Hang on, we can... This doesn't need to be if junk length is equal to 0, because it turns out when junk length is 16, we're still sending another 16 bytes of padding to exhaust the junk, which we don't need to do. So if the junk length mod the block size is equal to 0, special case because we've made a mess, does this just work now? Yes, it does. Let's take that back to I and I. For I in range 128, let's keep it nice and reasonable. Let's do all the possible junk sizes up to 128 bytes. Like that feels exhaustive enough to me, rather than randomly jumping all over the place. Let's do it with prepended junk min-max being II, which means the junk will be length I. In fact, we can assert, oops, we can assert that the length of oracle.junk equals I, else, oops. Get the res and then assert that the res equals the flag. Looking good. No complaints yet. All right. We've now got a function to leak the suffix from an appending ECB oracle that tolerates any amount of prepended junk, including 0 bytes of prepended junk. And so this function here, which relies, this leaker, which relies on this interrogation function to just get things like the block size, the junk length, and the suffix length, and implicitly ensure that the oracle is working in ECB mode. That is a basically drop-in replacement for what we did in challenge 12, which was to do the same leaking over an oracle that prepends no junk. Whereas the one in challenge 14 works even if there's junk being prepended by the oracle. So I'm pretty happy with that. And I'm happy that we didn't go and shove this leaker into utilities, because this one's better. This one's more flexible. How did we do it? Yeah, as I said, we adjusted this interrogator. A lot of the heavy lifting happened inside this interrogator to basically also figure out the length of the junk, which we did by repeatedly tacking stuff onto the end of the junk, essentially, until we were able to induce two adjacent blocks of equal ciphertext, which we induced by having two adjacent identical blocks of plain text. We just had to find this padding that would line them up and block align them. So a lot of the hard work was in getting the length of the junk. Once the length of the junk was gotten, it was... I mean, I might see if I can tidy up some of this code offline and, I don't know, think about if I can do any better than this mess here. But once we had that length of the junk right, a lot of it just became accounting for that junk in our building of the aligning chunk. We had to create some padding to exhaust the junk, and then we had to do this awfulness in here to make sure that during our brute force, we were focusing on the block that we were causing our brute force to happen in, and basically skip forward past the junk. So I'm happy with that. And then the previous episode, or the previous challenge, was ECB cut and paste, where we started off doing things the hard way, and then ended up basically telling our URL encode function to please don't break hex 7, hex 8, hex 9, whatever we needed to... I just realized that there's not a bug in here, but there's a limitation in here, actually. But we did ECB cut and paste, where we basically caused the word admin to appear in its own block, and then just sliced that block off and then tacked it onto the end. No, I'm focusing on the wrong thing here. Here is... No, block admin. Block admin is where we caused a block to have just the word admin in it. And then we basically caused the oracle to create us some ciphertext where role equals ended on a block boundary. And then we just replaced the last block, which in this case would have been user, with ours that says admin. So ECB cut and paste. That's kind of cool. Now, the thing I've realized is that this function will only work for roles that are less than the block length in length. Yeah, it won't even work for something that's equal to the block length, I don't think. Let's quickly run this function. Role admin, that works fine. Let's yank this and paste it. Craft profile. Role is Z times 15. You know what? Let's do this. Role equals role. Role equals Z times 15. Assert role equals role. Whoops. And run this. That's fine. But as soon as we do 16 Zs, I think it's going to blow up. Yeah, it blows up. Oh, it blows up real bad, actually. So, that's fine. We were only asked to produce role equals admin. So we can delete that little ditty there. And up here, we can assert, no, if the length of role is greater than or equal to block size, raise value error, role must have len less than block size. And we can write a test case to ensure that that raises profile equals craft the profile CT with the oracle being oracle.encrypt. That's fine. And the role being Z times 16. That's as soon as it starts to break. Run the tests. Yeah, good, we got yelled at, which is what we want. Pinch this. And pinch this. Now we've got a test case to ensure that we are successfully yelling at the caller if they give a roll that's too long. Yeah, good. So they were both quite cute challenges. Things are starting to feel like they're heating up a bit. I feel like I probably need to go through and tidy some of this up, but I'll tidy it up offline. Maybe. We'll see. And then I'll do a git push and get that up to GitHub if anyone wants to take a look. But that's going to be it from me tonight. Thank you very much for sticking around. If you're watching on YouTube, thank you very much to you as well. Do we want to raid anyone who's streaming software stuff tonight? If you'd like to stick around with me and say hello to Key Login, if you're watching right now on Twitch, we'll do that. Let me start that raid. Alright, so if you'd like to join me, click the join raid button. We'll go say hello. But otherwise, I'll be streaming sometime in the next couple of days. I'm not sure when. Follow me on Twitch, on Twitter, on Mastodon, and you'll find out when that is. But until then, I hope you've enjoyed yourself. Thanks for sticking around, and I'll see you on the next one. Bye for now.